Welcome back, everyone, to our session on automating Industry 4.0, maximizing production with the power of data. So with the amount of interconnectivity, digitization, analytics, and automation that Industry 4.0 brings, there's an opportunity to mine and refine data in multiple ways, which will unlock significant value. But with great integration comes a lot of data. How do you use it to the best of your advantage? Let's find out from Jiani Zang from Persistent Systems. Using examples from Samsung, Porsche, and Bosch, she'll explain how they worked out the problem and used data to improve performance, amongst other things. Just a quick introduction to Jiani. Jiani is the president of the Alliance and Industrial Solution Unit at Persistent System. Jiani has extensive experience in management consulting, marketing, product development, and technology management. Prior to Persistent, Jiani also served as the Director of Offering Management for IBM Watson's IoT platform and Head of Offering Strategy for IBM Industrial IoT, where she pioneered the creation of the industrial analytics, AI, IoT solutions. Over to you, Jiani.
Hello, everyone, and thank you for giving me this fantastic opportunity to speak with you all today on the exciting topic of Industry 4.0. My name is Jiani Zang. I am the president of the Industrial and Enterprise Alliance unit here at Persistent Systems, and have the pleasure of, interacting with a lot of clients that have been the Industry 4.0 journey. Just quickly, I wanted to cover who we are as Persistent. Persistent is a digital solutions company enabling our clients in software engineering and digital transformation for our clients for over 30 years. We operate worldwide in over 16 countries with more than 12,000 employees, and we're really there to support our customers in the digital transformation from taking advantage of technology, from software to cloud to data and AI, to really help them transform their business. And because of that, we come very often to Industry 4.0, especially as we work with industrial customers. Although I would say that Industry 4.0 isn't unique to just manufacturing and industrial. So what is Industry 4.0? I think most people already by now have heard of the term Industry 4.0. It started, I would say, in the hype about 5-6 years ago, where really the kickoff was Internet of Things, IoT, right? And then, there was so much excitement on the possibilities of a smart device, from smart light bulbs to smart home to smart everything. And then the concept went a little bit further to say beyond consumer products, the smartness can be adopted in industry. And that smartness kicked off this whole movement of the intelligent industry, of the intelligent industry 4.0, and really started to marry a lot of the excitement around connectivity with digitization, with the possibility of using the data, applying the data with analytics and getting to automation. So Industry 4.0, like I said, is not really a new concept anymore. Now, as you look at this very interesting graph, and I'm sure you've seen variations of it, you see Industry 1.0, which is mechanization, and 2.0, and electrification, assembly lines, and mass production. People start to get confused. Well, what's really the difference between Industry 3.0 and Industry 4.0? We're also talking about computers, right? Cyber physical, digital computers. We're also talking about automation. So why is it different? And I think the uniqueness in Industry 3 versus Industry 4 is that Industry 4 is even more interconnected. You're not talking about a piece part. You're not talking about one section of the assembly line. You are talking about the entire value chain of the industry, whether that's manufacturing or others. And when you think about that, it becomes an incrementally more challenging problem, because now you're talking about beyond what you think of as a spot process. Now you're intersecting your processes across the value chain. What you design is what you manufacture, is what you service, right? Your customer demands affects your inventory, affects your output. And so all of those things start to come together. And that's why this I would say magnificent idea of Industry 4.0 and the whole idea of cyber and physical convergence becomes really an amazing venture for all of our clients and all of the industry to pursue, because ultimately you're going to be driving to a state of interconnectivity and automation that you've never seen before. And that will yield significant business value for you across the board. And so, I think for Industry 4.0, although it is a concept that a lot of us have heard about, the actual understanding and the actual application of Industry 4.0 is still very much to be experimented, acted, and executed on in really to be able to see value. So the Industry 4.0 idea actually has now become even more accelerated with the pandemic, right? So the pandemic has really challenged industry, has really challenged the concept of manufacturing, for example, and staying within the four walls, because now you can't go into the four walls. So the pandemic has compelled organizations to really think about Industry 4.0 adoption in a very different light. For one, companies who have already started the adoption of Industry 4.0 now has a competitive advantage. They're better positioned. They already have started that digitization journey. They've already started to be less reliant on the specific on-prem systems or the within the four walls operations. They have their processes better mapped out so that they can start to move toward a new form of work, a new way of work, because of what the pandemic has forced upon us. The second piece to that is an increased focus on emerging technologies. The pandemic has really shaken us up in terms of what we used to do things. And any type of, I would say, distrust or skepticism on, the technologies like AR, VR, and things like that has really changed, because we now have to work in a remote fashion. And so the adoption of these emerging technologies, the adoption of technology in digital twins and cloud, have been forced upon us. Now there's no longer a choice. There is no other way of doing it. And so that really has changed the mindset of the speed and need of moving to Industry 4.0. And then the final piece really is the enterprise priorities, right? For every major company, there's always going to be a ton of priorities that they need to evaluate. Is it the right time to make an investment to do an Industry 4.0 adoption? And oftentimes, these types of new accelerations come up against a lot of resistance, because it costs money, it costs time and effort. And, I'm already doing fine. Why fix it if it ain't broke? But the reality is that it can't function like that anymore. The pandemic has showed us that business resilience and business continuity are at risk, and that without having another form, another method for us as a backup plan, even to be able to change the way that we work, to be able to leverage technology in order for us to have continuity and profitability, is no longer acceptable. So because of that, I think Industry 4.0 has also been given another lens now with the push of the pandemic. So I want to cover a couple of key companies here, I would say, who are leaders in Industry 4.0. And they've all sort of adopted Industry 4.0 in sort of different ways. And so, in each of these cases, I just want to highlight that what was their drive in actually going for Industry 4.0. So let's start with Seagate, right? Seagate is a large scale semiconductor manufacturing company, hardware, right? And for them, the big challenge was the cost of counterfeit electronics. The issue is that when they build a hard drive and they ship it, and then people use it, consumers or or enterprise, when it becomes time to service, there's the issue of, wait, is that really a Seagate product? And so they've implemented and used blockchain, and IBM blockchain specifically, in order to help put on an extra layer of security. They've added an electric fingerprinting and a secure electronic ID in order for them to tag the products that are actually theirs, and so that they can actually understand and be able to service their customers and have these have measures against counterfeiting in order to have integrity in their products. And so it is estimated that the full implementation of this will benefit from a global value perspective of upwards of $1.7 trillion. And that's an enormous figure. So that's both in terms of their business value, but also of the greater business value. Because when it comes to counterfeiting, then municipalities, government, everybody starts paying for it. So that improved transparency, that improved security, and that overall good is what drove them to act on Industry 4.0. Now let's take another example like Samsung, right? For Samsung, the benefit of Industry 4.0 is really on quality and on control. For them, there are key disadvantages to a very manual inspection line of LCD panels. And so they needed to look for a new way, leveraging technology to 3D scan a visual inspection of their product. And by doing that, they can quickly pinpoint the problem. And by pinpointing the problem, they can resolve it and drive up their quality. And so that type of Industry 4.0 application allows them to get to less than 1 second in inspection time. And that obviously leads to better quality, higher production, and overall value for the company. And then we have examples like Bosch and Porsche, both of them leveraging very state-of-the-art, very exciting new technology in order to increase resiliency, increase agility, and efficiency of their manufacturing lines. So Porsche deploys a flexible AGV assembly line. That's an automated guided vehicle assembly line. Very interesting in how, instead of thinking about an assembly line as static, it's on a line, people work on a line. It is a mobile line and adapts to where they need the help. And it gives you that extra bit of flexibility and agility and changes with the way that people need to move, because the whole point of Industry 4.0 is that we are rethinking the way that we are doing things, leveraging technology and applying technology in new ways in order to drive better results. And Bosch, as I mentioned, also leveraging state-of-the-art technology in what they call an APAS robot, APAS robot, which is effectively, a robotic production assistant that's works with the employees in improving the overall effectiveness of the manufacturing line, collaborating with the employees in helping with inspection and things of that sort. So very interesting technology. Again, really blurring the lines between what's digital, what's physical, what's robotic, what is employee, and using all of that information and data to really drive fundamental business results. So when we look at Industry 4.0, the application of Industry 4.0, just as in the examples I've just given, are not specific to a certain area. You'll see here that regardless of its design or engineering, manufacturing and operations, or service and support, all of those elements in industrial value chain can already leverage the benefit of Industry 4.0. We're not even talking about beyond industrial here, right? Industry 4.0 has impact in retail, has impact in transportation. It is across industries. It's not just for manufacturing, but even in manufacturing, it's applied in very different ways across very different parts of the value chain. The examples that I've given, like Bosch, Samsung, and Porsche, you can see fit mostly in that manufacturing and operations middle pillar there. And that's consistent with what we see in terms of adoption here. So, about 76% of Industry 4.0 adoption sits with manufacturing operations. But of course, there's other parts of it too. So services and support, as the Seagate example, is meant to help showcase, is that what happens after a thing is built and it's now out in the wild, right? So do we have confidence and security on that is our product, that it performs to how it is, how it needs to be, and how the quality of it will then drive back to the production or to the design of it. And so services and support leverages Industry 4.0 as well. And then one area a lot of people don't think about is actually design and engineering. Well, if you think about design and engineering, this is where your product is being incepted, it's being prototyped. And now today, more and more products are smart. They are highly software driven and highly integrated. And so actually Industry 4.0 becomes critical in the software engineering and the design and engineering phase of any product, because that process, that smartness, that data and digitization needs to occur early. And so there is absolutely application of Industry 4.0 in design and engineering. Now, having spoken about all the great and exciting things of Industry 4.0, I do want to mention that there is actually quite a lot of resistance in adopting Industry 4.0. And today, you know, the enterprise obstacles are very much real. And talking to our clients and working with our clients, you know, this Industry 4.0 concept and the application of Industry 4.0 is an issue. And you can see some of the issues that's listed here, right? So, you know, starting from things like limited management buy-in to inability to scale up, or not a well-defined roadmap, and so on and so forth. And you say, well, it has such great promise, why is the management buy-in so limited, or why is it so hard to scale? And as we explore this with our clients, we found that much of the root cause and much of the failures of Industry 4.0 stem from technology. The reality of when an enterprise starts engaging on a digital transformation journey and engaging in an Industry 4.0 roadmap is that they start to look at what they have today, and they realize the complexity and the interconnectivity of their existing legacy systems that cannot transform with them in Industry 4.0. So the technology is confusing. The legacy systems are highly complex, highly interconnected. It's like a spider web of complexity. And because of that, it's very difficult to scale. And so then it becomes an even bigger question of, is it worth it? You know, is the promise of Industry 4.0 really great enough for us to go and untangle, you know, the mess that we have stuffed in our closet for the past 20 and 30 years because it's worked? And I think the early adopters that you see here have just made a decision that it is worth it. Fundamentally, you're going to need to get to that next level of smart, because without it, you will not be able to surpass the new entrants that come into your market that don't have baggage, that don't have, you know, a closet full of skeletons and spider webs that they have to untangle. They will adopt new technology and they will surpass you. And so that challenge is very much real, and everybody kind of needs to have a level set and a big understanding of and reality check of where they are today, the investment that's needed to get to tomorrow, and make a decision of whether or not you want to make that investment for tomorrow. So it's very interesting, as I you know have highlighted already on, you know, the spider web and my various analogies of the entanglement of the legacy systems, on highlighting the need for digitization and the need for what the industry has been calling a concept of digital thread, right? And there's a lot of different terms for it. Some people call it digital thread, some people emphasize digital twin, and so on and so forth. But the concept is there is a fundamental digital layer, or whether we call it a digital thread, that ties together data that's being used across the value chain. And so in an example here, I'll just use the industrial value chain. It is data that is used in design and engineering, is used in manufacturing and operations, is used in service and support. That data becomes an underlying foundation that helps you tie these different processes together. And by understanding that digital thread, that digital layer of data, and how it intersects in these different processes, then you are able to then formulate a use case, or fundamentally a process that allows you to use that data for the betterment of your processes, for the effectiveness and efficiency of your processes. So the digital thread becomes a very interesting and important concept, but it's also a very difficult thing to map. So the example that's shown here is, there's some data that sits in as early as a PLM, product lifecycle management platform, on how you're actually going to set the requirements for building, the suspension thing on the right. So somebody has already put in, I need this type of requirement, I need this type of torque, I need this type of weight, whatever. And that data then doesn't stop at the PLM platform. That data gets moved to an integration layer that then is utilized manufacturing to validate that you're actually building what you intended to build and what you designed to build. And later on in service and support, if there is a failure, to help diagnose that failure. In manufacturing, digital thread becomes even more complex and important, because as many manufacturers go, they fundamentally rely on suppliers. So then requirements gets communicated to suppliers that then have to track the requirements in their system, production on their side, and sending it back to the OEM to actually put together. So there's a lot of important information that sits in this digital thread. Unfortunately, the digital thread is very difficult to tangle and disentangle from everything else, because I mentioned earlier, there's a lot of systems. There's a lot of fragmented silos of where data sit. And here's just a simple representation of where we see the complexity. You can see from a left-hand side all of these different functions that are calling for different types of data. And then they connect to all these different types of systems in the middle, ERP systems, MES systems, CRM systems, name your acronym system, to actually pull that data to drive to an end result. And so we're making the investment, you're thinking about approaching that Industry 4.0 journey, it is without a doubt that it is going to be complex. It is without a doubt that you're going to be touching your legacy systems. It is without a doubt that you will probably disrupt your current systems in order to untangle the mess so that you can leverage your data for the future. But at the same time, it comes back to, is it a worthwhile investment? And many of our clients and many of the leaders of Industry 4.0 really believe it is. And so, what you want to get to is kind of like this nirvana state. And this is not the only nirvana state. This is just one of the architectures that that can drive value for digital transformation. And there's a lot to see here on this chart. But fundamentally, the idea is that instead of all these disparate systems with their disparate data, that fundamentally gets collated into a digital integration layer, the light gray bar here on the bottom, that allows you to then access that data in various ways across various functions across your value chain. And that data is aggregated in, whether it's integrated, whether it's collected fully in a data lake, but fundamentally these digitally interconnected systems can then be used, and that data can be derived to be utilized to be able to generate insights. And that insight supports the automation that is required of Industry 4.0 along the value chain, not just in one spot location. So, getting to the data is obviously important and is already a huge challenge. And so I think as part of the sort of the hype of IoT, I would say, and getting to, the value realization of Industry 4.0, there's already a ton of debate on, what should be connected, what should I be collecting, how much data is the right amount of data, how do I get to my other types of data that hasn't been recorded? And that's only step one. Step two then becomes, how do you make use of that data? And then there's obviously another increasing order of complexity in the way that you utilize data and analytics. So whether your analytics is descriptive, whether your analytics is diagnostic, or really getting to that predictive, prescriptive, using it to drive automated actions across your assembly line, is another level of complexity. And each of these complexities and each of the needs will vary based off of the company and based off of the specific value that you're trying to drive to. So I think what's important to highlight about Industry 4.0 is that it has great promise, it has great results, but you also have to be very practical and strategic in how you choose your use case and how you decide to implement. Because if you try to disentangle everything, then you're trying to boil the ocean, and that's not going to drive the ROI that you want to see. But if you pick too small of a piece that you want to POC, proof of concept, and then kind of just let it sit there, then again, you're not getting to that scale. You're not getting to the values and the return on investment that you're looking for. So it's a balance. It is a balance between what's important, what's strategic, what's applicable, what's adoptable today, and the technologies that you want to utilize. But I think, as I've reiterated in the point before, Industry 4.0 is here to stay. It is benefiting the early adopters, and it is driving results. And fundamentally, when you get thrown something like a pandemic, you start to see the value of that investment that you've made to be proactive. So finally, I wanted to cover a couple of cases of customers that we've supported in terms of the Industry 4.0 application and adoption. The first one is a global automotive supplier, and we did this exact exercise with them, which was, take a look at your complexity and the disparate systems that you have today. Let's figure out what's important to you. We then built a architectural roadmap, kind of like what I had shown before, on what are the pieces that are important to you. Then start to heat map out, these are the areas that they feel like would drive the most ROI if they were to go and implement that. And so utilizing that, we built together sort of a digital integration layer for manufacturing visibility and performance. And that visibility really drove to better understanding of their inventory, better understanding of their demand collection from their customers, and how that demand collection can then be used as important data for the speed of production as well as industry inventory count. And then also, how to take advantage of some of their quality data to really enhance their PPAP process, the production part approval process, because they are a supplier, and really drive down those information. So absolutely worthwhile exercise, because fundamentally they are able to drive substantial return on investment by going through somewhat of a painful, realization and investigation of what they have today. Another case that's here is an oil field services leader. And for them, it is really about the modernization of applications, because you get to a point where your legacy applications just can't cut it for you, that there isn't going to be the right data access that you would need. And so a lot of it then becomes, well, if I have to, coexist with my legacy applications, how do I build new applications that help me with my operations, that help me optimize my process or environmental impact and whatnot? And then the conversation becomes, well, then I'm building a new application. What kind of application should I build? Or how do I modernize my existing application so I can take advantage of things like hybrid cloud and containerization and things like that in order to drive value? So very different forms of Industry 4.0, one that fundamentally looks at their process and their process chains in order to automate and get data accessibility. The other one, looking very much toward fit for purpose, digitization, application building that's specific to their needs, and using that as the driver for Industry 4.0. So I'll sum it up with, I don't think anybody can do it alone. Fundamentally, to undertake an Industry 4.0 transformation is a huge change. And it's a huge undertaking for any company. And like I said, one of the most difficult things to overcome is technology. And so I fundamentally do believe that any industry, any company will need guidance on how to do something that enormous of an effort. But it's very worthwhile, as I said, for the leaders that have approached Industry 4.0. So whether you're looking for help in terms of technology skill sets or complexity and change or architectural guidance, I think service providers such as Persistent can be very much a help for our clients, help guide them on what's the reality of their current systems, and to be very practical about what can actually be done and what can't, and what types of ROI you would face, right? And also in the cases I mentioned earlier, how much of your existing process you want to salvage versus how much of your current applications you want to modernize and change and rebuild. And so I think in that situation and with all the entire market, Industry 4.0 absolutely exciting time for industry transformation, and service providers are here to help regardless of the piece of support that you need. And I think together we can create the digital transformation that we're all looking for in order to drive to the new industries of tomorrow. So thank you very much for your time. I hope you enjoyed this talk, and I hope this was interesting for you. And appreciate this Integr8 for this opportunity to speak with everyone. Thank you.
Welcome back, everyone, and thank you so much, Jiani. Please accept this virtual certificate, and we will be planting a tree in your honor to say thank you for being part of Integr8 2021. Okay, we will see you after the break, where we'll hear from Jerry Bindra talking about the virtual world and the changes it's brought in. Jerry, of course, being the MD of Chorus Call, which is the fantastic platform that we've been using for this conference for the IACC in partnership with Automation Alley. So we will see you on the other side of the break with Jerry. Thank you.